Hello my dear friends, I warmly welcome all of you to a very special program of my YouTube channel. Today I have a NASA scientist, actual NASA scientist as my resource person, as my guest. Before all, I will give a very brief introduction about my friend, Dr. Henry Throop. Dr. Henry, who is having his PhD in astrophysical, planetary and atmospheric science, is working as a program scientist in the Planetary Science Division at NASA headquarters. On the other hand, he is a reputed researcher who has published over 40 research articles in reputed journals based on the topics such as astrobiology and the origin of the life, then the planet and solar information, planetary rings, and so on. So today I invited Dr. Henry Throop to my channel not to discuss about NASA astronomy, NASA space voyaging, or anything about space administrated related thing in NASA. But today I am going to allow you to know the educational aspects of NASA with aid of our Dr. Henry. So Dr. Henry, I know this topic. It means NASA educational aspect is still remain as a hidden part to the countries like Sri Lanka. The reason is our people don't know about the NASA educational things. They know about the rocket voyaging, the space voyaging, anything about the NASA, but they don't know about the educational aspects about the NASA. But if you are watching this video from beginning to the end, you will know everything about the NASA educational programs, NASA funded programs, MSc and PhD programs, and the correct way to join with NASA educational programs. So I think now you are very excited to know these things. Therefore, let's begin our discussion. So Dr. Henry, I would like to warmly welcome you again to my YouTube channel. I want Dr. Henry.
Thank you for having me here.
So as a beginning, Dr. Henry, could you please give me a very brief introduction about you? I did the normal brief, but I would like to have it from you.
Yeah, thanks for having me here. It's a pleasure. So I have a PhD in astronomy from the University of Colorado in 2000. And I got into astronomy because I really I was very curious. I was very interested in exploring the world around us. When I was in secondary school, I took a physics class. I had a fantastic physics teacher, and I learned so much from him, and he made me so curious about exploring the world. So I studied physics as a BSc, and then I went on to apply for and get a PhD, an MSc and PhD in astronomy. And what I do as a career, I spent about 20 years doing research in the solar system. So not outside the solar system, not black holes, not galaxies, but the stuff inside our solar system. Things like the planets and the asteroids and the spacecraft that NASA is using to explore them. And now I'm working at NASA headquarters, which is in Washington, D.C. And at NASA headquarters, I help to manage our research programs and our science programs in the solar system, specifically in the outer solar system. So that means planets like Jupiter, Saturn, Uranus, Neptune, like Pluto. These are the sorts of, that we have a lot of research programs to study to send spacecraft out and to study the origin and evolution and the physics going on in these bodies in the solar system. And those are the programs which I'm involved with.
Very well. Now our viewers know very well about you. Now, can you give me a very brief introduction about the NASA? Not the everything about NASA, but the big picture about NASA.
Yes, so NASA is the US government's space organization. NASA stands for the National Aeronautics and Space Administration. And NASA is the largest and the first space agency in the world. It was founded in 1958. It's based in the US and it's funded by the US government. And NASA's vision is to explore the universe for the benefit of humanity. And that's NASA's job. So to drive forward our exploration and share that with the world for free. NASA is not a company. NASA doesn't make money. In fact, NASA spends money. And NASA spends money for the benefit of everybody on Earth. And so this involves a lot of research and exploration, for instance, inside the solar system, beyond the solar system. There's the division of NASA, which I'm in, is the science division or the science directorate. And so we do science in my division in the solar system. We also study the sun. We also study the Earth. There's many studies of the Earth from orbiting satellites of the Earth, where we're looking at, for instance, the atmosphere of Earth, for instance, climate change, for instance, sea level change, ocean temperature change. Since the Earth is, our home planet and maybe the most important planet to us in the solar system, then beyond the solar system, we study the Milky Way galaxy, and we study the galaxies beyond that as their role to show us the origin and evolution of the whole universe.
Yeah, when we are talking, that is a very interesting topic. So, Dr. Henry, now I will come to our original question. If I ask you, what are the educational paths available in NASA, what would be your answer?
So NASA's job is to do research and exploration throughout the universe. And a very important part of that is the research which is done with students. So a lot of the research that NASA does is done at the different NASA centers. We have about a dozen NASA centers across the US. But an equal or larger amount of the work that NASA does is actually done at universities. And so NASA sends grants or sends contracts to universities, and universities will perform that research with an agreement with NASA. And so, for instance, there may be a project to study Jupiter that's at one university, or there may be a project to build an instrument to go to Pluto at another university, or another university may have a telescope which is either sent up into space or used on the ground to study different things in the solar system or the universe. Other nonprofit organizations can also apply for grants through NASA. And all of these places, students are some of the best people to do research, right?
Yeah, they are very curious. No?
You were a hardworking student, I know.
Enthusiastic.
And you work with some great students, and NASA works with great students too.
Actually.
And so having students work on these NASA projects is such an important part. There's student involvement in probably the majority of NASA projects, which are funded at universities. And those would be either students at the BSc level, in the US we call them undergraduates, or students at the postgraduate level, at the MSc or PhD level. And many NASA projects, for instance, are awarded to professors, and the professors, as part of the research, will employ students to actually do that research. And that means the students are the ones who, in many cases, go to the telescope, or who use the data, download the data, write the results under the supervision of the advisor. And there's so much work, so much research, which is really, maybe done under the direction of the faculty member, but is undertaken by the students. And so this is all work which is funded by NASA, done at universities, and then published publicly for the benefit of humanity.
Perfect. That is very clear explanation. Then assume a person is willing to join one of those NASA educational programs. So how he and she join the NASA educational programs? Can you explain the exact path? The reason is people don't know the exact way of joining those programs. That is the reason in our country, in Sri Lanka, they don't know about the NASA educational programs. Even though they don't know the exact path. So could you please tell us the exact path of joining those NASA programs?
Of course. So there are many students from around the world who are in the US at universities. So many international students. And all of these students have applied for admission to the universities in the US and gained that admission. And once they are students at a US institution like a US university or college, then they can participate in the research projects which are funded by NASA or funded by any other part of the government or anything else at these universities. And so there's many international students. When I went to university, I was in the US at University of Colorado. There were many international students there. People who had applied and then come to the US for their postgraduate studies. And there's many Sri Lankans who study abroad in the US and in other countries as well. There's many people from India and from Europe and from Australia, all who come to the US and to other countries for their postgraduate education.
Excuse me, Dr. Henry, it means if any person is in interest of joining NASA education, first of all, they have to come to USA, no?
Yes, so NASA funds these projects at the universities. NASA is not a university, right? NASA doesn't give a degree. There's no NASA university. There's no NASA college or NASA certificate or anything like that. But what NASA does do is fund the projects at universities. So in order to participate in these projects, you must be a student at these universities in the US.
Yeah.
And so in order to be a student...
Specifically in US.
That's right.
It means does not NASA fund any project to the outside of US?
NASA is the US government space agency, and so the vast majority of projects that NASA funds are in the US. There are certainly some international collaborations. So NASA, for instance, works a lot with different space agencies. For instance, the space agency in India, the Indian Space Research Organization, ISRO, and with ESA, the European Space Agency. And NASA works with universities in other, across the world. But for the most part, because NASA is the U.S. government's space agency, the money that that NASA pays is for universities which are in the US.
Yeah, that is the reason they need to come to the US if they are willing to have a NASA educational program, no?
That's correct.
Right. Now, great. Now, our friends know the exact path to join NASA educational programs. Then, Dr. Henry, can I know about the universities which carry NASA degree programs? You told that so many USA universities are having NASA degree programs. It means NASA funded degree programs. Can I know about them? Several as an example.
So, yeah, there are so many different universities. In fact, there's so many that I'm not going to list them. And NASA-funded projects happen at almost every large university across the country, and there are hundreds, and there are hundreds of universities and thousands of institutions across the U.S. that have been funded by NASA. And so, you or anyone watching this knows the name of a bunch of large universities in the U.S. Certainly, those all have NASA projects. But there are many smaller universities as well that have equally, very competent, very excellent research programs. For instance, there may be researchers which specialize in one particular area who are at a smaller university, and maybe researchers at a larger university are specializing in this area or that area. For instance, a different type of modeling or a different type of laboratory work to study the atmosphere of Jupiter, or building different hardware to send to the planet Mercury, or building, a different spectrometer to study the temperature on Venus, or things like that. And so every researcher has their own niche. And so because of this,
limit, no?
We have research programs across the spectrum of universities in the US.
Yeah, it means they are not only the undergraduate programs. No, undergraduate means engineering programs, BSc, then MSc, PhD, and postdoc. That is a huge variety, no?
That's right. And so there's NASA-funded projects kind of at all levels. There's even, so at universities, right? So there's many BSc and BE level projects where a professor has funding, and then they employ students either during the year or over the summer when there's classes are not in session to work on the projects. And then at the MSc level and the PhD level, that's kind of where the independent research or large publishable research projects are kind of dominating. And I should say that also there's many areas of NASA education which are done at even a broader level outside of the university system. For instance, there's many movies and films and so forth that NASA puts together, interviews, public shows, programs, things like that, which NASA does distribute worldwide to anybody who's interested in them, whether you're enrolled in a university or not.
They don't need to be university, If there's an organization which is having the capability of working with NASA, they can do.
So a lot of these public programs, for instance, there's a lot of material on NASA's YouTube channel, and these are kind of streaming shows and so forth, which NASA produces to tell about the research and to tell the stories that we discover, and to tell do interviews with researchers, with scientists, with astronauts, things like this, to tell the story of the research and exploration that NASA is doing.
Now, Dr. Henry, you told me about so many educational aspects and so many educational paths in NASA. But the now problem is our people don't know, they don't know the exact place where those opportunities are available. I think in NASA original website, their mother website, those things are available. If you can show them, it would be a very great help for our viewers. Could you please do it?
Yeah, let me give you examples of a couple of different NASA sites.
That is fine.
Where people can go to and where they can see this. So let me share the screen here.
Yeah, that is fine.
So here's an example of one of the websites which NASA does. First of all, everything is available at the huge NASA website called nasa.gov for the US government. This is a brand new website called NASA Plus, and this is a streaming website where there's a lot of feature movies and documentaries and so forth, which is about the work that NASA is doing. So you can find that at plus.nasa.gov. So this is not education which is happening at a university, but this is kind of worldwide education and telling the stories of the work that NASA is doing. If people go to the NASA YouTube channel, this is one which I've participated in a number of different events, such as the solar eclipses, such as the live launches of the spacecraft that we have. We had a really exciting event a couple of months ago where we brought a sample back from an asteroid. So we had a spacecraft called OSIRIS-REx, and it went up to an asteroid, retrieved a sample of that asteroid, and brought it back to Earth. And so there were millions of people watching that in return to Earth as this capsule was coming back from the asteroid in Bennu and landing in the Utah desert and then being successfully retrieved. So this is the NASA YouTube channel features. The most exciting thing for me is the live coverage of the launches and other special events like that, which is featured there. And telling these stories is a really important part of the education that NASA does as well. Moving more over onto the research side and how people can participate in some of this research, whether you're at a university or not, there's a really neat site which is funded by NASA and other groups called Zooniverse. And what Zooniverse allows to do is what we call citizen science. And so this is where everybody can participate in contributing to these research projects. And so there's many citizen science projects where, you know, a normal NASA mission might take millions and millions of images. And historically, we've always used individuals to look through those images. And, you know, one scientist or two scientists or even 10 or 20 can't always do that themselves. And computer AI is getting better and better, but sometimes human AI is still, human intelligence is better than computer AI, right? So we have a lot of projects there on Zooniverse where humans can contribute to this. For instance, by looking at NASA images and saying like, oh, these galaxies are classified this way, or this is a lunar crater and this is not a lunar crater. And so by millions of people contributing to this, then together, everybody helps make the science happen. And so the site that hosts this is called Zooniverse. And then within Zooniverse, there are dozens of different projects, and many of those projects involve NASA data. Many of them involve other citizen science projects too. So there's a big diversity of both NASA and non-NASA projects on there. Here's an example of one of them, which is looking for pulsars. And so this is called Einstein at Home. And so anybody can look through and look at the data on these pulsars to try to identify these things and contribute to the science which is being done there. One thing which I really love, I've been involved with a number of times, is called the Space Apps Challenge. And this is an international project. It's a global project. You may have had some students who've been involved with this. I know there's been some Sri Lankan teams in the past who have done this. And this is a hackathon. You know, it's like, let's get a project and let's, hack on it for 48 hours straight or 72 hours straight. And I know sometimes these groups just never sleep because they're given the project and then it's like all out to try to come up with a good solution for it. And so there are maybe several dozen projects every year, and there are thousands of teams from around the world who contribute on this. And some of the projects are involving, like I was involved in one last year that was a way to image and project and visualize data from the Juno mission, which is one of NASA's missions at Jupiter. And so it has a camera, but the camera kind of is, operates in a different way than a normal DSLR camera would. And so there's actually software required to make the images from the raw data images into a beautiful picture. And so the hackathon project was to basically do some image processing to make these images really, impressive, so you can see what's going on in Jupiter's clouds and atmosphere. And so that was a really, really fun project. So this comes up every year. I think it starts in October. You can see all the projects from the past years now and get ready for that for October when this is going to be run again in 2024. I think the Space Apps Challenge is great. It's open to everybody in the world, everybody in the universe, as long as you can get to the website, which is as listed there, spaceappschallenge.org. And I encourage people to look at that because it's really cool.
Okay, Dr. Henry, now our people know the exact way of joining NASA educational programs. If you go to those websites and if you go to those forums, you can join. Actually, you can join. That are the things. And Dr. Henry, when you describe those things, one thing came to my mind. That is the research publication. It means if the NASA is doing so many research, they must publish it. So could you please show me the peak research publications of NASA?
Yeah, of course. All of NASA research ultimately is published, and NASA is required to publish this data and the research available for free for the whole world. And so even before the research makes its way into papers, what NASA does is makes the data, the raw data, available for free. And there's a couple of, so let me just take you through the whole process of how these research programs work. Is that a university or an individual would apply to NASA and get funding to start this project, and then they would go to a website to download the NASA data, and anybody on Earth can download this NASA data. It's not limited to just the US people or citizens or anything like that. Anybody from Sri Lanka, any other country, can download all of the NASA data from all of our spacecraft. And so here's an example of one NASA website. This is at the PDS, which is a planetary data system. And this is where all of NASA's data in the solar system comes down. And so you can go to this. It's at pds.nasa.gov, pretty easy. And here, then you can click on the sort of data that you want to look at. If you want to look at data from the atmospheres of the planets, or if you want to look at the data from the surface of the planets, or if you want to look at the rings of the planets, so forth, you can find the right thing there. And then you kind of click on the planet over here, and then it would give you all of the data available from the various NASA spacecraft from those missions. Now, it can take a lot of work and background and understanding and coding and so forth to actually interpret that data. That's essentially what people go to school for and do a postgraduate degree for, is because, some of the data, sometimes it will look beautiful and will look like a picture right there when you download it. Many times it needs a bit of cleanup, or it will be in a different format, like a spectrum, for instance, in which case it requires quite a bit of work or modeling or other processing in order to use it. But that's where the data comes from, okay? That's the stuff in the solar system. Everything there in the solar system is available at the PDS, the Planetary Data System, which is part of NASA. Everything from some of our large space telescopes, like the Hubble Space Telescope and the JWST, the James Webb Space Telescope, which well here. All of these are archived at a different NASA website called archive.spsci, that stands for Space Telescope Science Institute.edu. And this is a place called the Mikulski Archive for Space Telescopes. And so from there, you've seen all these Hubble images and all these JWST images from all around the universe. Looking at I just saw one this morning. It was the oldest galaxy ever found. A couple 100 million years after the beginning of the universe. And those data, you can download those and look at those data and process them and do science publications on them from this website right here. So visit the MAST, the Mikulski Archive for Space Telescopes, and anybody around the world can download those data. If you're looking for publications, so a scientist might take a year sometimes to go from looking at the data to writing a publication on it and presenting it to their colleagues.
Dr. Henry, as an example, shall we type your name? Then your publication will come.
Okay, so here I'm at what we call the Astrophysics Data System. And so this is an archive of scientific research papers. And so it's an index of all of the papers in the field, or almost all the papers which have been published in the field of astronomy and much of physics as well. And this is in part funded by NASA.
Yeah.
And anybody can go here. It's a free system. And not only is the index, the list of the papers available, but many of the papers themselves are available too, including almost all new papers, which are funded by NASA research. So if you just enter here, we can enter my details here and click search. And it's going to load up research papers which I've been involved with.
Wow.
So here we have, so this is a presentation about this is actually about a presentation which we did at a conference recently about a program which NASA has for supporting undergraduates. And so this is to involve BSc students in NASA spacecraft planning. This is called the H2O, the Here to Observe program. And then there's, let's see, here's a discovery paper of some new trans-Neptunian objects. These are basically things which are out well beyond Pluto, but sort of the same idea as Pluto. They're small icy bodies of the outer solar system. And so we have short papers on these. This is a paper about the current research happening in planetary rings. This is a research paper that came out of the New Horizons mission, which went out to the outer solar systems of past Pluto and to a Kuiper Belt object named Arrakos. And all of these, you can see these are team papers. I don't think I was the first author on any of these papers here. Well, here's one that I was the first author on. This is where we were looking for rings around this object called Arrakos, which was small Kuiper Belt object about the size of Colombo. It's about 20 kilometers by 30 kilometers, something like that. And it's about 6 billion kilometers out in the solar system from us. So now you can go through all the 7 pages of publications which come up, and all anyhow, there we go. So this is examples of the sorts of things that you can find here. If you want to learn more about these research papers,
then you just have to go to the website and search.
That's right. So the ADS is just a fantastic place to look for. Use this. Don't use Google directly, but go to the ADS, the Astrophysics Data System, and it will. It's really the place to go for doing science, for looking for the papers which NASA and NASA-funded work are publishing.
One question, Dr. Henry. Aren't those things available in NASA official website? When you go to NASA official website, can't you see those things?
This is a NASA-funded website, but this is not on the NASA website itself. So what NASA does is, some of the work that NASA does, it funds and does itself at the NASA Center.
This is a common thing for the astronomical research,
project. No? That's right. So this project is funded. This index here is funded by NASA, but it's actually developed and run not at NASA itself. So it's not on the NASA website, but it's on, in this case, the Harvard website, because they've developed this database.
Got it. Fine, Dr. Henry. Now our people know the exact place of that research bank. Now, could you please carry on your presentation about that researching?
Sure. So let me just show you a couple of examples, because I know that sometimes people hear about NASA research and they don't know, what really does that mean. Let me just show you a couple of examples of these research papers.
Yeah, that is very.
These are just research papers which I happen to have and been using. So let me share those here. So these are papers which I found using the Astrophysics Data System, this search engine here. And for instance, if you're looking for Jupiter, you can enter Jupiter up there. You can find all sorts of results that this is sorted by maybe the most recent or most relevant topic about Jupiter. There's some about comets there. Here's a paper about the Europa Clipper mission, which is a NASA mission which is going up to orbit Jupiter and study the satellite Europa. It's going to go up in October. Real exciting. Launched in about 6 months. Here's another website that you can look at. This is archive.org, ARXIV, and this is a complementary, second website and search which hosts a lot of papers which are freely available. So all these papers here you can download from the archive site, and many of these are NASA-funded research. So here's just an example of what does a research paper look like. I have 5 or 6 of them here just to show you what they are. Here's one which is looking at a molecule named glycine. Glycine is a very simple amino acid, and so it's an organic molecule, which we think might be related to things about the origin of life. Certainly, glycine is a chemical which is necessary for life, and so here's a paper where these authors are looking at the origins of glycine and whether you see that out in interstellar space. What we mean is the space between the stars, out beyond the solar system, in clouds of gas, essentially. So there's a paper about that. Here's a sort of paper where this is from, this is 44 years ago, 1980, but this is still a classic paper about the origin 1980. Of Jupiter's ring. So one of the things, I know,
classic paper.
Sometimes these old papers are still valuable. So this is a paper looking at the origin of Jupiter's ring. This happened just after Jupiter's ring was found, in fact. And so Jupiter has a very thin, very narrow ring. Saturn's not the only planet with rings, but Jupiter, Saturn, Uranus, Neptune all have rings. For my PhD, I studied the rings of the planets in the outer solar system. And so this is sort of one of the first models for the origin of Jupiter's ring. Uranus, here's another paper I happen to have, which is about the Uranus ring system. So Uranus is really interesting. We're working on, it's been a long time since we've been to Uranus. NASA sent the Voyager missions, which you probably know about, launched in 1976, 77, Voyager 1 and Voyager 2, they're still out there. They're just amazing spacecraft. They've been going for almost 50 years. They're not sending back images anymore because essentially there's nothing to look at out there anymore. And the power available to run the cameras and the health of the hardware isn't good enough to take images anymore. But they're reporting on things like the strength of the solar wind and the magnetic field and so forth in, again, what we call interstellar space, which is what's in this case beyond the planets in our solar system. And so Voyager is super duper important to to everything we know about the outer solar system. We're hoping to send a mission to Uranus in the next, as a future, what we call a flagship mission, a very large mission in the future from NASA, and with details of that, that we're trying to work out now. So here's a paper based on some observations from the ground it looks like observations taken from the Hubble Space Telescope of the Uranian ring system and additional rings that were discovered there. This is something outside the solar system. This is what we call a circumstellar disk. And so this is essentially a ring which is going around, not around a planet, but around a star. And so this is the sort of thing which might form in, after the stars form, where you have a disk of material, or sometimes it's well after the star and its planets have formed, and there's dust, what we call kind of like a debris disk of leftover material, sort of like the asteroid belt. And dust that's produced from the asteroid belt in these stellar systems. So this is one where the dust went away and then it came back in this particular observation. So this is taken with a looks like a Japanese satellite and a NASA spacecraft called WISE. Here we have a result which is from New Horizons mission. This is a mission that I was involved with, which went out to Pluto. Really exciting. We spent 9 years getting out to Pluto, the first mission ever to go and fly past Pluto. Before we went out to Pluto, it was just 1 pixel across. Afterwards, we had about 5,000 pixels across on the surface of Pluto. And so many of these people here involved in this work are on the New Horizons team. There were many students, and many of these people were funded during their PhD research by NASA, and so NASA really trains these students, and then they become NASA-funded scientists. Here's one on studying asteroids. Asteroids are really an exciting topic now. In this case, we're looking at the composition of asteroids and the organic molecules that asteroids have in them. This is something this is an older result here, where they were looking at organic molecules, hydrogen, carbon, oxygen, nitrogen, and the molecules that those elements make up. That are found on meteorites that come from an asteroid. I mentioned earlier that we had the OSIRIS-REx spacecraft that brought back a chunk of an asteroid back to Earth. And so you can bet that one of the things that NASA is involved in is comparing the sorts of the composition of this OSIRIS-REx sample from the asteroid Bennu and seeing how that compares with the samples from meteorites, which are chunks of asteroids which have landed on the Earth after going through the Earth's atmosphere. So here's one more from New Horizons. I guess I've been looking at lots of New Horizons papers recently, just because that's my main interest is the outer solar system. These papers are not in any particular order; they're just ones that I was looking at recently. But here's one that's about the observations from a instrument which is actually built by students. So this instrument on the New Horizons spacecraft, it's out at 6 billion or more kilometers out away from the solar system. That was built by BSc and BE and MSc, PhD students at the University of Colorado. And the instrument, in fact, is called the Student Dust Counter. So this is maybe the best example, or one of many great examples of a student-built instrument which we're sending out through the solar system because students and education is so important to NASA, and on and on. But those are some examples of the sorts of research and the sorts of papers that NASA research ends up in.
Beautiful. Those papers are amazing. And if you're joining with NASA education system, actually you also can publish so many papers. Then your name will be at NASA paper. Then it would be a very validity for you. It would be a very good opportunity for you. When you do so, you will be a world recognized scientist. That is a way of joining with NASA, and that is the ultimate objective of joining with NASA. And Dr. Henry, as the conclusion of our video, could you please give a message to the people who are willing to join with NASA education programs? I know people who are watching this video are in need of joining NASA education system. If they don't have the enthusiasm, they will not watch the video. If they are watching the video to the point, the reason is they have the enthusiasm, they have the need in themselves to join with NASA. Could you please give a final message for them? It would be a very amazing encouragement for them.
Of course. So what I encourage people to do, find the thing that you most love doing, because that's what you're going to be the best at. Whether that's in astronomy, whether it's in physics, whether it's in IT, whether it's in graphic design or writing or education or whatever that area is, that's what you're going to be the best at. Follow your education as much as you can. Then, if you're looking for postgraduate programs, look at postgraduate programs that are funded by NASA projects if you're interested in the sorts of things that NASA does. Look at postgraduate programs all around the world as well, but look at also at the ones which are funded by NASA, where you can work on these NASA projects. And these are all of these are competitive. They're for people who are at the top of what they're doing, who have spent spent a lot of effort to do work and be persistent and work hard and really find out what they love doing the most. But there's possibilities for everybody, and I'm encouraging everybody to follow.
Marvelous, marvelous. I think we were able to deliver great message through this small video. Since now you have a clear idea of NASA educational path, I invite all of you to use those paths wisely, and I invite all of you to use those opportunities wisely. So Dr. Henry, thanks a lot for allocating your precious time for this video, and thanks a lot for sharing your precious knowledge with us. Actually, this is a huge service, and I will be very thankful to you, and I will be very grateful to you on behalf of each and every viewers of this video. And Dr. Henry, thank you. Actually, thank you very much.
Thank you so much. It's a pleasure to be here.
And also thanks all of you for watching this video. At last, I invite all of you to share this content. The reason is, if you're sharing this content, people who are in need of joining with NASA will be able to find this video. And also you can comment your issues, and also you can comment your ideas of this program in the comment section. Then I will help you to get them solved. And if there is anything which is not in my subject area, I will pass them to Dr. Henry, and he will give me the ideas. Then I will pass you those ideas. If you comment them, then we can discuss. Actually, that is a way of learning, and that is a way of gathering knowledge. So my friends, this is the end of today's program. Again, Dr. Henry, thanks a lot for joining with me. Actually, this was a very huge service for the people who are in need of joining with NASA education programs. I think now they know the exact way of joining NASA education programs. I think now they know the benefits which they get if they join with NASA education programs. They just have to go to that website, then they have to apply, then they have to choose their programs, then they can follow. That is a way of joining with NASA. Dr. Henry explained each and every part of them from beginning to end, step by step, very clearly. And at last, I would like to be thankful to you again. Thank you very much, Dr. Henry, for joining with me. And with that effort, I'm winding my program. If you have anything to tell, now this is a chance for you, Dr. Henry.
Thank you so much. It's a pleasure to be here. It's a pleasure to talk with you. You're doing, it's so nice to be able to talk with NASA, or talk about NASA with so many people here. And thank you so much for having me here.
Okay, thank you very much. And for my viewers, I ask all of you to share this video, comment, and express your ideas in the comment section. Then we will be able to discuss. So thank all of you to watching this video, and I'm winding this one. Thank you.